Problem 4-40. Solve each of the following systems algebraically. What do the solutions tell you about each system? Visualizing the graphs may help with your description. Starting out here, problem A, we have y equals 3x minus 5 and y equals negative 2x minus 15. Let's start out here looking at trying to solve this one. They're both equal to y, so probably the easiest way to do it would be either what we consider the equal values method or substitution. If 3x minus 5 equals y and negative 2x minus 15 also equals y, then we know that they equal each other. So let's go ahead there and substitute one of our expressions in for y in the other equation there. So we have 3x minus 5 equals negative 2x minus 15. Now it's just a one variable equation. Let's go ahead and solve it. Add your 2x to each side. And I'm going to move my constants over to the other side, so I'm going to add a 5 to each side. You can do that in separate steps if that is the way you are used to solving it. So 3x plus 2x gives me 5x. Negative 5 plus 5 gives me 0. So all I have on this side is 5x. And that equals negative 2x and positive 2x gives us 0. Negative 15 plus 5 gives us negative 10. Finish solving it. 5 times some number equals negative 10. Well, we know then the value of x would have to be negative 2. Now these are systems of equations. So remember, systems of equations have solutions that are ordered pairs or points on a graph. We're given x's and y's in our problem here, so you're thinking about you have to have x and y's in your solution. So we have the x coordinate of our point, which is negative 2. We need to go back and find the y coordinate here. So we're going to take it and we're going to go y is equal to 3 times negative 2. We're just substituting it in here. Minus 5. 3 times negative 2 is negative 6. And then minus 5 will end up giving us y equals negative 11. So we're looking right now at our solution being the point negative 2, negative 11. Let's check it by plugging it into the other equation. We've got negative 11 equals negative 2 times a negative 2 minus 15. Well, there's no simplifying over here. It's already simplified. Negative 2 times negative 2 is positive 4. So we have positive 4 minus 15 equals negative 11. And it just so happens that 4 minus 15 is negative 11. So negative 11 equals negative 11. We are good there. We know that this ordered pair, this point, is the point where our two lines intersect on the graph. So it says, what do the solutions tell you about each system? We can add in a little description here. So for system A, we can say the system has one solution. So it has one solution because there are two intersecting lines. And one more time there, our solution was negative 2, negative 11. Let's go on to B here. We had the system y minus 7 equals negative 2x, and we have 4x plus 2y equals 14. So I think the easiest way to solve this, I'm going to take it here and I'm going to add 7 to each side. So what I'll end up with over here is going to be y equals negative 2x plus 7. So I just simply added my 7 to each side there. And now I'm going to take this expression and I'm just going to substitute it in for y in this expression. So what we're looking at is 4x plus 2 times the quantity of negative 2x plus 7 equals 14. Let's simplify this side here. We still have 4x. 2 times negative 2x would be minus 4x. And 2 times positive 7 would be plus 14 equals 14. Well, what we're going to see here is that our 4x and negative 4x are going to cancel out and give us 0, leaving us with no variables in the equation. And we have left over 14 equals 14. That is true. And since that's a true statement, we can say here that we're going to have infinite solutions. We're going to have infinite solutions. This means that any number that we take and we plug in, or any point that we take and we plug in there, should end up working. And the reason why is because these two lines are the exact same line. These are what we call coinciding lines. If you're a little unsure about that, put this in. You can put both of these into slope-intercept form, and you will end up here that they will both be the same thing. This would also be y equals negative 2x plus 7. So you can go ahead and try that if you still don't see it. Let's move on to problem C. We have the system y equals 2 times the quantity of x plus 3 squared minus 5, and y equals 14x plus 17. This one's a parabola, this one is a line. So think about the different possibilities you could have between a parabola and a line intersecting each other. I feel like the easiest way to do this one, I'm going to go ahead and just do substitution again. I'm going to take this expression, and I'm going to, since it equals y, I'm going to substitute it in for the y in the other equation here. So we've got 14x plus 17 equals 2 times the quantity of x plus 3 squared minus 5. Now to simplify this down here, I'm going to go ahead here and multiply my binomial times itself, or square it there. So we'll have here 2 times x squared plus 6x plus 9, still in a quantity here in parentheses because we're still multiplying it by 2, minus a 5 equals 14x plus 17. Now let's distribute our 2 through. Distribute the 2 through here. And we should end up with 2x squared plus 12x plus 18 minus 5 equals 14x plus 17. Combine our like terms. We've got 2x squared plus 12x plus 13 equals 14x plus 17. Let's combine our like terms or set it equal to 0. So I am going to, whoops, I forgot my x over here. Let's make sure we don't lose track of that. There it is. So minus 14x. Let's subtract 14x over here. Let's subtract 17 from each side as well. So we now have 0 equals 2x squared minus 2x minus 4. And now we have just a quadratic. So we can look at the next step here is how do you solve this? We always want to check to see if we can factor first. And that first step in factoring is finding the greatest common factor. 1 does exist here, and that would be the number 2. So we're going to factor out 2. So we're going to have 0 equals, and remember 2 just doesn't disappear. It is still part of your expression to start out here. So I'm going to take my 2 out. 2 times what is 2x squared? Well, that would be x squared. 2 times negative x would give us negative 2x. And 2 times negative 2 gives us negative 4. This trinomial will also factor here. So we're going to say 0 equals 2 times, I have our two quantities here. We're going to have an x, a minus 2, and a plus 1. Now the next part that remains, or the next part that we still need to do here is we still need to use the zero product property. If we have 2 times the quantity of x minus 2 times the quantity of x plus 1 all equals 0, then we need to figure out what values of x would make this expression equal 0, or what would make this expression equal 0. So we're going to say here that 0 equals x minus 2, or 0 equals x plus 1. Solve that. We're going to get x equals 2, or x equals negative 1. So we have the x coordinates of 2 of the intersection points. To get the y coordinates, let's take it and let's plug it in. So we're going to say here, let's do, I'm going to plug it in the bottom one because it looks a little bit easier to work with there. We have y equals 14 times, in the first case we'll do 2, plus 17. 14 times 2 is 28. 28 plus 17 should be 45, so y should equal 45. So one of our solutions here is the solution 2, 45. Our second solution, when we take our negative 1 and we plug it in, let's see here, we're going to have y equals, sorry I have to jump up here, I'm running out of room at the bottom. We're going to have 14 times negative 1 plus 17. Well, 14 times negative 1 is negative 14, and negative 14 plus 17 should give us 3, so y would equal 3, giving us our second intersection point at the point negative 1, 3. Now how can we check these? Well, you've been learning a variety of ways to check them. You could take this point or this point and one at a time plug them into the other part of the system to check to make sure that that is true. If not, then you probably made a mistake somewhere. You could also graph each of these on your graphing calculator. But remember, what we're looking for here, that second part of the question asks us, so we scroll up here, what do the solutions tell you about each system? Well, in this case, it's nothing super fancy. It's just that our parabola and our line intersect in 2 points. So let's make sure we answer the question. Our parabola and our line intersect in 2 points. And those are our 2 points. All right, last problem here. Let's go ahead here and get started on it. So we have D. We have y equals 3 times the quantity of x minus 2 squared plus 3. and y equals 6x minus 12. So once again, a parabola and a line. So the last one intersected at 2 points here. What are the chances here that these ones are going to also intersect at 2 points? Or do they give us something a little bit different to see? So let's go ahead and solve it pretty much the same way. Let's do substitution. Let's take our 6x minus 12, and since it equals y, let's plug it in for y in the other equation. We have 6x minus 12 equals 3 times the quantity of x minus 2 squared plus 3. Let's simplify this side here by, first of all, multiplying our binomial times itself. So we're going to have 3 times, and when you do that, you should get x squared minus 4x plus 4. And then at the end here, remember you're adding 3 still. And let's distribute our 3 through here. We're going to have a 3x squared minus 12x plus 12, then plus another 3. And combine our like terms there. We're going to end up with 3x squared minus 12x plus 15. And bring down our 6x minus 12. Let's go ahead and subtract it from each side there so we can get everything together, get it set equal to 0. So we now have 0 equals 3x squared minus 18x plus 27. This is quadratic. First thing we want to check is, will it factor? And it definitely factors. We have a greatest common factor that we could take out first. That would be 3. So we take out that 3, and we've got x squared minus 6x plus 9 equals 0. This is a perfect square trinomial, so it factors into x minus 3 times x minus 3. That equals 0. So now you can use your zero product property. 3 times the quantity of x minus 3 times the quantity of x minus 3 equals 0. So do we need to set them both equal to 0? If you want, you can do that, but if you just think about it here, you're going to get the same answer. You're going to get x equals 3. Now, if x equals 3, that's going to be the only value we're going to have to take and plug back in to figure out what y is going to be. Let's extend it just a little bit here. So I'm going to take y equals 6 times 3 minus 12. 6 times 3 is 18. 18 minus 12 is 6. So we get y equals 6. So that intersection point we have here would be the point 3, 6. And what does that mean? We have a parabola and a line, but they intersect at only one single point. So if we're trying to come up with a little description here, we could say the parabola and the line intersect at one point. So if we're going to be a little bit more descriptive on this one, so since they intersect at one point here, so the line must be tangent to the parabola. Dusting off a little bit of that old geometry terminology there. So a parabola and a line, they intersect at one point. That means that this line should be tangent to that parabola. If you don't remember what that looks like, go ahead there, graph them on your calculator, and you'll see what we're talking about there. All right, I hope this has helped you out. This is the problem 4-40. Once again, just for the solutions, we had -2, -11 for A. For B, we had infinite solutions. Remember, they are coinciding lines, or the exact same line. For C, we had our solutions were 245 and -1, so there were two intersecting points. And there was just one intersection point for D, and that was the point 36. Please remember, though, the descriptions are also part of your answers there, so don't overlook those. All right, this is Mr. Boyd signing off.